And this has to do still with statistics that we've been talking about, but now we're going to be using tables and graphs. So again, this is homework 15 notes for my open math. Now, a basic frequency table, and really frequency is what we're talking about, something that happens how often, how frequent does it happen. So you're kind of going to be counting things, basically. So a frequency table has two columns. You're going to have a list of all the categories that you're talking about, and the second is going to list the frequency. So really this category and frequency part of it is you're just going to be counting how many of a category you have. In this case, this first one, A's, B's, C's, D's, and F's. So you're going to have that written here, and you're just going to count them. Then when we talk about relative frequency of any category, that is the fraction or percentage of the data values that fall in that category. So you're just going to take that frequency amount and use that in order to find either the decimal or the percentage for that. So we'll go over that in a little while. So let's look at the very first one. What you're going to do is you're going to come up with your categories. And actually, sometimes that's given to you, but in this case, it's pretty obvious. Let me get my pen going. Then we're going to be talking about A, B, C, D, F, because that's all that's listed here. A teacher makes the following list of grades so that she gives her 25 students. Sometimes you're given the total amount, sometimes you're not. If you're not, you would have to go in and count this and make sure there's 25 of them. I mean, you could count them and say there's 25, but so let's look at all the A's. So maybe you underline them and make sure you got them all. But it looks like there's 4. Now you could make tally marks as you go, 1, 2, 3, 4 like this, and write 4. But you don't really have to do that. So let's say you're going to look at the B's next. So I want you to pause the video and go through and do that for all of that. So the B's would be 1, 2, 3. Oh, I missed these. 4, 5, 6, 7. Okay, so I'm going to pause that and go through it. Okay, so you should have gone through and finished counting all the A's, B's, C's, D's, and F's. Now, it's very easy to skip one. And you may want to do different things like I did. Underline all the A's once. And you can do it how you wanted to. The B's, I did squiggly lines. C's, you could make little marks above it or something. D's, I put a little box around it. F's, I just put a little arrow. You can do however you want. And then this number right here, there's going to be a checkpoint where if you add these up, it should give you a number. What do you think that should be if you added that up? It should match either whatever they give you as the total in the problem. There's 25 students, so that's kind of my checkpoint. If you don't get this number, if these aren't right, if you miss one of them, it's very easy to miss one of them, then it's going to mess up what you're doing for the rest of it. So check and make sure that your total here is the same thing they give you in the problem. And remember, if they don't give that to you, I could just go through here and count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's 25. So either check it in the problem or actually count them and make sure it matches this. Okay? Now, to find relative frequency, kind of like your relatives are related to you, how does this particular category, A, with a frequency of 4, relate to everybody? It's kind of like what we do with part over whole. So if you're going to do 4 over 25. And then to find the, now that would be to find the decimal, you could do that. But if it says to find the percentage, you would do times 100. So let's go ahead and do that part because I don't think it actually says on here which one. So hold on just a minute. Okay, so I have my calculator. I can do 4 divided by 25, and I'm getting 0.16. So if they ask you for the decimal, you could stop here for the decimal. But what if they wanted the percentage? You would just multiply that times 100%. Times 100, or 100%, equals 16%. So they could either ask you for the percentage, or they could ask you for the decimal. Okay? Now, let's just pretend like they're asking you for the percentage on this, and we're going to kind of skip the decimal. But you see that you could do both. I hate to do that. Hold on, let me just look at something because I think I should show you the whole thing. Let me just see. Okay, so on this example, let's do that. Let's do 7 over 25. Let's do find the decimal and then also find the percent. Next time we'll just do the percent on these, but let's do both the decimal and the percent because sometimes I think they ask you for the relative frequency as a decimal. Most of the time you'll go ahead and go to the percentage. So on this one, what I want you to do is do the rest of these out like this one. So that would be 7 over 25. Remember, it's part over whole. 7 over the whole thing, 25. And then you're going to find out what that equals. 7 divided by 25. Well, let's see. 0.28. And then I need to multiply that by 100% to get the percentage as well. And that, or we could just think about it as moving 2 decimal places to the right, 28%. So you could do that either way if you remembered that it goes 2 decimal places. Or you could multiply it by 100. I want you to finish these. Do the rest of these 3. So pause. I'm going to pause this. I want you to finish that, and then you can turn it back on. Okay. So if they ask you for the decimal, you would give this line here. 0.16, 0.28, 0.36, 0.12, 0.08. I wonder what that would add up to be. Let's see. I'm going to pause this, and you add it on your calculator. Add up that list of decimals. Okay, so when I added that up, it adds up to 1. Okay, that makes sense because altogether it should come up with a total of 1 with the decimal and 100% with the percentage. So you're looking at all the grades in the class. There's 25 students, 25 grades, so altogether that's 100% of the students. So the percentages and the decimals just kind of break it apart into the groups where you can see which one's weighted more heavily. So which one has the most percentage? We got 16%, 28%, 36% C's, and then 12%, 8%. But altogether, that's 100%. That's all of them. So that's kind of another checkpoint. Now, sometimes if you're rounding, the numbers are out real far and you've rounded them a little bit, you may be a little bit above or below a 1 here, and you may be a little bit above or below 100%. Like you might end up getting 99.78 or something. You're close to 100%, and sometimes that's just rounding. So this one we didn't have to worry about that here. Okay, I think that's it on this one. So all this is the category and the frequency. This is really called a frequency table. Frequency table. And then if they ask you for the relative frequency, that's where you have to do this part. And normally it's going to be the percentage that you need on a lot of this stuff, but they may want it as a decimal. So it's good to know both ways. Here's the percentages, though, that you would need. Okay, the next one. Consider the following 20 scores from a 100-point exam. Okay, now they're giving you something here. A 100-point exam just means that the scores are out of 100. But what does this 20 scores mean? Does that mean the total? So if you counted this up, you should get there's 20 of them. Sometimes that's given to you, sometimes not. And then looking at the category, usually you're going to be given this. But what is the lowest score? I see some 70-somethings. Actually, this is a pretty good group of scores for an exam, because I think they're all A's, B's, and C's. Now, the smallest one looks like a 72. Excuse me, I'm sorry. And it goes up to less than 100. So you could do 70s, 80s, 90s, but that's not very, that'd be all clumped together. So maybe we could do this. Maybe we could go 70 to 74. And usually this is going to be kind of given to you on this part, but that would be 5 of them, wouldn't it? 70, 71, 72, 73. That's 5. And then 75 through 5, 6, 7, 8, 9, 79. 80 through 84, 85 through 89, and so on. 90 to 94, 95 through 99. So each of those have 5 in each one. Okay. Frequency. Now here's where I think it's a little bit harder to see, but you're going to count up the numbers that are from 70 to 74. Well, there's a 72 and a 72, 74, 72. Now, we're not going to include 75. We're just going to do those. So there's 4 of those. And then 75 through 79. Ooh, there's quite a lot of those. 1, 2, 3, 4, 5, 6, 7. And then 80s. Let's put a little maybe an arrow on it. 80 to 84. 80 to 84. Here's an 84. We're going to skip the 88 for now. 81. And that's all I see. Now, it's very easy to miss one, but just write your numbers in. You can always go back and change them later. 85 through 89. Oh, sorry, not that one. 80, I meant to circle 88, 86, 88. So not the 84. I never can get my eraser to work right. I think it's just messing with me. Oh, maybe I just don't know what I'm doing. Okay, so, all right. So 88, 86, 88. Okay, so now, what do I have left? Oh, here's some 90s. Oh, we had already done these two as well. Okay, so we did the lower 80s. Oh, now we did the upper 80s, 88, 86, 88, and 90s. 94, I'm going to put a box around that. Not 98, 91. I'm doing my lower 90s. I see 2. And then, well, I think there's another one, but I'm going to pretend like I didn't see that. And let's say I even put a 0 in here, and I added these up. What should I get when I add these up? Do you see that there should be a total of 20? So if I got something like 19, I would know that I need to go back. So I should get 20. That's our checkpoint. And if I added those up, that'd be 11, 14, 15, 17, 18, 19. Uh-oh. then I know that I've gone wrong somewhere. And that's where maybe that comes up where I didn't see that 98. Okay, so that makes it 20. So you always want to check here. That's kind of just to point that out. It's very easy to miss one of those. Okay, so we've got my 20. And now you want to check that before you get over here and do all this work, because what if we did something wrong there? What if we left one of these out? Like we left one of these out, or maybe more than one. So we're just going to do the relative frequency. How are they related? We're going to do part over whole. So what number do we put on top? And then we're going to put the total on the bottom. Okay? Part over whole. Okay? Or you can just think of it as this part over the total. And then just, we're going to do this straight by just going ahead and multiplying it by 100 and get the percentage. So we're going to act like they're asking us for the percentage. So I can do that all together. 4 divided by 20 times 100. I'm getting 20%. Because remember, when you multiply by 100, you're really doing times percent. Or you could have come up with a decimal and then moved your decimal point 2 places to the right, 20%, and that would be fine. So I want you to pause the video and do the rest of these. And just kind of doing our shortcut, we're going straight over to the percentage. So do the rest of those. So hopefully you got these same things. Now remember, you could have done 7 divided by 20 and written down the 0.35 and just move your decimal 2 places to the right to get the percentage. Or you may want to do it in all one swell foop. That's the way my mom said it one time. We just laughed. One fell swoop is what it's supposed to be. But 7 divided by 20 times 100 will give you that 35% as well. So of course, when you do 3 divided by 20 and multiply times 100, you're going to get 15%. And you get the same thing for this one, so you don't have to calculate it again if it's the same exact thing. But once you do these, what should these all add up to check yourself here? If I did my percentages correctly, shouldn't I get 100% total? And remember, if you're dealing with decimals, take it out further, then it wouldn't be exactly 100%. But that one should really add up to exactly it, because you didn't have to round anything on these. When you did 7 divided by 20, you got 35%. So, and I mean, actually multiplied by 100. So if I did 20 plus 35 plus 15 plus another 15 plus 10 plus 5, I'm getting 100%. Okay. Now, remember, it's not always going to be that nice, because sometimes you may have rounding going on, so it might be a little bit off from that. Okay, so let's go on to the bar graph. So a bar graph shows each category with a bar whose length corresponds to its frequency. To construct, draw a vertical axis and horizontal axis, and we'll do that in just a minute. The vertical direction will have a scale and measure the frequency of each category. Make sure to label. So let's think about that. So the vertical axis will be the frequency. So if they mean to label it, what are we counting here for a frequency? Was how many, was the grades, wasn't it? So you would need to go ahead and put that in over here. So we can just write frequency for now. Oops. I'll tell you what, instead of me trying to write this in, but you would write frequency over here. I'll show you my other one that's already written on that's a little bit nicer than this, than me trying to write on this thing. And along the bottom here is going to be whatever else you're talking about. So we're talking about the frequency of the grades. Okay? So grades would kind of go along here. All right, so what else did it say? It said, measure the frequency of each category. So we want to write our categories in too. And really, since we're talking about frequency that's going to go on the y-axis, you may want to look at the numbers that are here. Like, does the frequency go up into the hundreds? Or no, what's the smallest one is 1, and what's the largest one is 7. So you'd want to at least have your frequency of going up 1 to 7, but maybe we can just go up 1 to 10, something like that. And then along the bottom here, we've got our A's, B's, our grades, A, B, C, D, F. Okay? And we're going to have to title that, so we'll do that in a minute. So frequency. So here is where this is always going to be 0 right here. And we can actually make marks going up. 1, 2, 3, 4, 5, 6, 7. We want to at least go up one more than the highest one, 8. Maybe even a little bit more. And then grades. We would have A, B, C, D. We don't have an E. F. Now, one thing about this is I might have even should have spread them out a little bit more, and I'll show you my other one in just a minute, is bar graphs are not going to touch. You're going to have a bar coming up for each one of these that corresponds to how many that you had of those grades. So if you look back up here, how many... Oh, you know what? I'm looking at the wrong one. I think that's why I'm... This is supposed to be up here. I was looking at the second example, and we're supposed to be looking at the first example. So we are going to have, that's why I was getting myself confused. Sorry about that. We're going to have 10 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we definitely want to go look at the other one. You're going to have 10 of those. And up here, frequency. So instead of going 1, the second one was 1 to 7. We just want to go up a little bit higher than that. We're looking at this first example. This makes much more sense to me. Frequency, 1 to 10. We got that. And then our categories is going to be A through F. Okay, so I think I was just thinking it was the second one. So let's switch over and look at this in just a second. A's is going to be how many? 4. I want you to make your bar graph, but do this. Let's write in, so the first one is going to be going up to 4. So you draw yours. You're going to go up to the frequency with which you have an A. A's in that class, which is up to 4. The top of it should be where the 4 is. Now, the B one is not going to touch it. It's going to come over a little bit. You're going to start another one here. Now, how many B's do we have? 7. So this one's going to go up to the 7. And then you're going to do the same thing for C. So I want you to finish that. Look at your first example. How many C's, how many D's, how many F's, and remember they're not going to touch. So finish that, and then we'll switch over to our other one where you can see it. Okay, so once you've drawn those in, you should see that they're not going to touch because it's a bar graph. You should put a title in and just make sure that the top of these match the frequency. So you should have the top one is a 4 here, 7, 9, and then what do we have? 3 and 2. You don't have to write those numbers in, but just make sure that your graph, if you come over here, it matches what those are. And then that's it. So bar graph, if you're asked to do a bar graph, remember that the bars don't touch. The bars do not touch. Okay, so down here, example 4, the bar graph, this bar graph shows the percentage of students who received each letter grade on their last English paper. The class contains 20 students. What number of students earned an A on their paper? Now there's a couple of things to note here. The frequency is how many, but this is also based on a percentage. I don't know if you can see there's a little percentage after that. Okay, and we're talking about there's 20 students. What number of students earned an A on their paper? Well, if you look at this, if this is on percentage, you can kind of see that this looks like A's is 25%. B goes up here between 30 and 40, 35%. C's is kind of here again between 20 and 30, 25%. And then D's is 15%. Okay? So again, just to check myself, these should add up to 100%. So we're talking about a whole class here. All together it should be 100%. So if I add all that up, the 25 plus 35 plus 25 plus 15, I should get 100%, and I do. Okay, so now notice that they're wanting to ask about something here. What number of students earned an A on their paper? So we're only going to really use mainly this A percentage here. So we figured that out by looking at the graph. Okay, so we can actually use that, remember the, I think of it as percent over 100 equals part over whole, but I think when we talked about it, we kind of talked about it backwards than that. So I'm just going to write them both up here. Part over whole equals percent over 100. Okay, so part over whole. Now in the problem it says something about 20 students right here. The class contains 20 students. Is that part of the class or the whole class? Isn't that the whole class? That's everybody. That's the total or the whole. Do they tell us how many? No. Is a part. We don't know how many, we just know the percentage. We know the percentage by figuring out by looking at the graph. Here's my A's, was about 25%. So remember, I just put that as 25 over 100. And then anytime I have a proportion, a fraction equal to a fraction, I can then cross multiply. So that'd be 100 times x equals 20 times 25. So we're going to be multiplying diagonally. Product of the means equals product of the extremes. 100 times x equals, we put equals in the middle, 20 times 25. So we have 100x equals 20 times 25, which is 500. But we want to get x by itself. So remember when we're doing these equations, we're going to try to get x by itself. So we're going to divide by 100. Since I'm multiplying 100 times x and I want to get rid of it, I'm going to divide both sides by 100 and get x equals 5. Okay, now if I got some huge number here, I would know something went wrong, but part of doing this is figuring that out. So part of 20 is the 5. Now, really, you could have actually just looked at this and known that we have a whole class of 20 and 25% of them made an A, so 25% of the class made an A, right? So we could have just changed that to a decimal, 0.25 times how many in the class, and you'd get your 5. Okay? So as long as you're showing your work somehow, then I'm okay with you doing it this way. Like, okay, because I would have kind of thought about that way. Well, 25% of the students are making an A. So what number of them earned an A? I can just say 0.25 times the number of students. Okay? Now I had to change the 25% to a decimal. So remember how to do that? That's where students get kind of messed up doing it this way because they forget how to do that. You either move it 2 places to the left or you can divide by 100 because 25% is the same thing as 25 per 100 or percent. 25 divided by 100 is 0.25. So once you change that to 0.25, then you multiply it times 20. Okay. Now we've done this before, so a lot of you are kind of thinking this way, like, okay, I don't know how many out of the total, so that's part over whole. X is my unknown. I don't know how many there are over my total equals, and we found the 25% by looking at this chart for the A's. 25, remember how we just put that in over 100? And then just cross multiply and go from there. Let's go to the next one. We're going to be using examples the numbers from example 1's information, not 2, 1. So go back to that first page and write those things down. Okay, so you have these percentages that we figured out from example 1. So in a problem like this, you may have to do that relative frequency thing first to figure out these percentages. Once you have the percentages, then you can do a pie chart. A pie chart is going to need the percentages to be able to do it. So looking at this, if we look at this as kind of like a big pie, I'm looking at just putting some little dots in here to kind of see what we're looking at here. So I would even start with either this 28% or even the 36%. Well, 28% is actually a little more than a quarter of it. Wouldn't a quarter of this whole thing be 25%? So a little more than that would make this the 28%, which is B. Now, the way I like to do my big chunks first. So we could go from here and kind of look at a third. So if you look at a pie, how would I make a third? Kind of goes like this maybe, where each one of these is a third of the pie. So, I might well even start here and go a third. But since we've already started here, we've gone over a little bit, we'll just make it come over a little bit higher over on this side. Okay, so that is going to be the 36%, which is C. Now, what do we have left? We've done those two. We've got 12 and 8, which is 20, plus another 16 is 36. So this area should be about like this area, okay? And we've got 12, 8, and 16. So the 16 is a little less than what the 20% of them together would be. So a little less than half of that is kind of my 16. Maybe I'll come up here and do it up here. %, which is A. And then I've got 12 and 8. And that is the F's, which is good. That's the smallest one. And D. Okay. So I'm trying to match what's going to be on your key that you see, but I probably would have done the 28% here and done like my 36 over here or something, and then gone with what's left down here. That's the way I kind of do it, but I wanted to match what was on here. But that's it. So in order to do a pie chart, you're going to need to know those percentages. Okay, the next example. So reading this, Logan categorized his spending for the month into 4 categories: rent, food, fun, and other. I wish that's all the categories I had to have. Rent, I got my food covered. Let's do lots of fun. Maybe make that one a big percentage. And then other. That could be lumped a lot of stuff in there. The percentages he spent on each category are in the diagram. If he spent a total of $2,400 this month, how much did he spend on food? So right there, they spent a total of $2,400. How much did he spend on food? That's part of it. So that's where you really should use that part over whole thing equals percent over 100. So back over here on that other example, where did we do that? You really should use it this way. I know you could. This one's kind of easier. You could figure it out, but you really should be using this right here and not using that. So if you go down here, we've got our total and our part. Now it says how much, so we don't know the part of that. So if we have percent over 100 equals part over whole, does it say anything about percentages? Oh, it says percentages he spent could be found or in each category on the diagram. We only need to look at the food part of it though. How much did he spend on food? That's how we know to look at that one. So talking about food, what percentage is that? 23 over 100 equals part over whole. Do we know how much was on food? No, that's our X, isn't it? It's our unknown. And a total of 2,400. So that's where you got to make sure that you put your 2,400 in the right spot. It goes on the bottom with it being the whole. Now I want you to pause the video and I want you to cross multiply and see if you can come up with that answer. So you could either start with 23 times 2,400 equals 100 times X, or you could do 100X equals the 23 times 24. It doesn't really matter which diagonal you start with. So go ahead and finish this and then turn it back on. So on this one, I chose to do 100 times X equals 23 times 2,400. Notice you've got your equal sign in between. I multiplied those together, 23 times 2,400. And then I noticed that I want to get X by itself, so I've got to get rid of whatever's being done to it. I want to get rid of the 100. So I divide by 100. Since I'm multiplying 100 times X, I'm going to do the opposite and divide by 100 on both sides. Remember, anything I do to one side of the equation, I got to do to the other. The reason I'm doing that is to get X by itself. So X equals $552. Now, make sure that makes sense. That should be a little less than a quarter of the total, which is 2,400. That could work. What if I got a number like 10,000 something? Well, that can't work because that's way bigger than the total. So make sure that your number that you get makes sense, because it could be that you put one of these in the wrong spot. Now I'm going to click over to my other one just to show you that you could have done this in a different way. It's the same way, but I mean, you could have multiplied the 23 times the 2400 first. So here's setup, the same setup. 23 times the 2400 could have gone on this other side, is equal to 100 times x. So it doesn't matter which way you do that. So you're going to get the same answer. 23 times 2400 is 55,200. And then you would need to divide both sides by 100, like we did. It's just not shown here. Divided by 100. And get the $552. Okay, let's go on to the next example. Okay, so a histogram is going to look very much like a regular old bar graph. It's a type of a bar graph, but a histogram is going to have some differences. A histogram is for quantitative data, and the bars have a natural order, and the bar widths have specific meaning. The main thing I want you to know is for histogram, the bars touch. Usually for a histogram, it's something like you're using those ranges like we did, and that's why we're going to use example 2's data on this. Okay, so let's see, the vertical axis represents frequency again. The horizontal axis is the number line representing the variable of interest. So whatever you're talking about as far as, I think that one had to do with grades, if I'm not mistaken. Let's go back and look. Yes, there's scores on an exam. So you're going to use these categories along your horizontal axis. And it naturally would kind of work as far as touching. It makes a little bit more sense that they touch. So let's go ahead and fill in, put frequency on your horizontal axis, and then put your ranges down here. And notice that the score started with a 70. So what you're going to do is, I'm going to show you on the other chart how you can start off with smaller numbers, like maybe 10, 20, and then we'll do a ziggledy line. So hold on just a second. Okay, so you may want to pause this and look at this, but first off, before you pause it, your frequency goes on this side, 0 up through at least 7. You really should go up more than 1. If the top one is there 7 is a frequency, then you go to 8. But down here, this is your ranges on your scores, on your grades. So write grades down here. And notice that we needed 70 to 74, 75 through 79. We need those up to 100. We really just need 70 to 100 or 99. So we wouldn't want to do 0 to 4, 5 to 9, 10 to 14, 15 to 19, and keep going like that, because then we would have run out of room. So what we can do is say, okay, we've got 0 to 4 and 5 to 9, and then we're going to go a squiggle. Okay? And then you can pull up your 70, 74, 75 through 79, 80 through 84. Those come straight from the categories, or from what we wrote in that example 2. The categories right here. Okay? So that comes from the categories on example 2. Okay? Or all those. Now, when you make the frequency chart, they're going to end up touching, because even if somebody made like 74.5, they'll be in here. You know, you're going to touch these. These are going to touch. So, what is the data that we got from 70 to 74 on that one? You look back up, it was 4, and then the next one's 7, and then 3, 3. So let's look at that. So make your bar graph go up to a 4. And then this one goes up, 75 to 79 went up to 7. And then these were both at 3. It's kind of hard to see, and 3. And then I think this was 2 and then 1. Okay, so this is a histogram. Histogram, remember the bars touch. Now, remember on a regular bar graph, they don't. But a histogram, they do. So don't forget about your title and labeling your x-axis. These are grades on whatever that was, and frequency. So the frequency is always going to go on that y-axis like that, unless they tell you otherwise. But put your frequency over here on the y-axis. 0 through, I would take it up even one more notch than the highest one, which was 7. So looking back up here, looking at our frequency, the frequency is going to end up being the y-axis. The highest one was a 7. I will go up one more notch. You don't have to, but I always had to for statistic classes that I've taken. I've taken a bachelor level stats class for business, and then I took a stats class for my master's, and they said to take it one more. So, of course, I wouldn't count off if you don't. We're not going to be that picky. I'm not going to try to do that to you. So, I say we. I'm used to teaching with another teacher, the 2 of us. But, okay, the last one, example 8. A group of adults were asked how many children they have in their families. The graph shows the number of adults who indicated each number of children. So over here, you're given this graph. Now, it kind of helps sometimes to write the totals on top of here. You don't have to. Like maybe even to check yourself, you could have done it back up here on your histogram. 4, 7, 3, 3, 2, 1. Okay, so on this one, number of children goes down here. And remember, your frequency always goes on the y-axis. And they've got this on here for you. So maybe look at what is the total then. A number of children is 5. So you may would go ahead and write that 5 in there. And then this one has the number of families that have 1 children is 3 families. 3 of them. How often did it happen? 3 times. And how many had 2 children? 4. 3 children? 2. 4 children? Nobody had 4 children. But there was 1 person that had 5 children. So, how many adults were questioned? Well, that's why it's kind of good to figure this out. You can take, well, there's 5 couples that have no children, or families. 3 families have 1. 4 families have 2 children. 2 families have 3 children. None of them have 4, and 1 family had 5 children. So you should be able to add those up. 5 plus 3 plus 4 plus 2 plus 0 plus 1. And you should be able to get how many they're talking about. Let's see. How many of their questions? That's what they're asking you. So you just add up all of those numbers that you figured out from looking at the chart. What percentage of the adults questioned had 0 children? Now, don't just say, oh, it's got to be 0 because there are 0 children. Well, remember that you can have a family and not have children, which actually I knew one couple that I went to school with. I graduated with the guy, and he had a girlfriend that was like 2 years younger. They dated all through into college, and they swore up and down. I remember she told me, she goes, I'm not having any kids. I'm like, why? And I think she just had a bad experience with helping raise the younger brothers and sisters. I don't know, because I've never seen that happen before. But out of everybody I know, most everybody that has gone on and had children, in fact, usually if you're from a big family, you want a big family. But I guess she was an exception to the rule, and they stuck with that. They had no children, but there's like the only people that I know that planned that and just didn't have any kids. But, so what percentage of adults questioned had 0 children? How many of the families? 5. Well, it could be that those are just young, couples that haven't had children yet. So I think if you wait until you're ready for it, well, it's going to be a blessing either way. Even if you're not quite ready for children, if you have children, it's all worth it. Everything is going to be okay. But just don't have a child just to have someone that will love you, or that you can love someone that will love you, because if it doesn't, it's going to take a while for the child to love. Now, they'll love you, don't get me wrong, but you're going to be spending a lot of time and energy and money and everything on the child, and sometimes that causes a lot of stress, especially for younger folks. And I've been through that, so that's the only reason why I'm saying that. But of course, like, I know, even though my first son, now he's 32 now, I told y'all this at the beginning, that, I went through a really bad divorce. I was young. I had gotten married right out of college. Anyway, I would have never traded that for anything, because I had my son, and we kind of buddied up, and he helped me weather the storm and get through all that. Don't get me wrong. But and I kind of instilled in my boys that it's best to wait, do this God's way, wait until, get married. That's what my older one did. He got married, paid off his debts. It was actually, his wife had student loans. He pretty much paid for stuff as he went, just because he was older when he went to school. But they paid off her student loans, and they've been married about 4 years. But now I'm like, okay, y'all paid that off, and you got your house now, so I'm ready for grandkids. But anyway, so I don't know how we got off on that. But hopefully these families that have no children will have them. We want everyone to have children. So that would be 5 families out of the total of 15, and these are adults, a group of adults, 5 adults out of the 15, and multiply that by 100%. Or you can get your decimal and multiply it by 100, or move your decimal, and it's 33.33%. So, and we would have told you where to round it and all of that. That looks like a repeating decimal. We would have told you where to round. But that really concludes this section. So remember, regular old bar graphs. And I should have asked you that. Is this a bar graph or histogram? This is a histogram. Histograms, the sides touch here. Now notice, if it's 0, it doesn't show anything on the graph. It wasn't shaved in here, so that these 4 adults had no children. Wait. No, I'm saying that wrong. There were no adults that have 4 children. These are the number of children. Okay, and then over here, number of children 0. These 5 adults have no children. This is talking about 4 children. There's no adults in that group that had exactly 4 children. Okay, so I want to get that clear. So that's a histogram because the sides are touching. This one was a histogram that we drew. And then earlier we did a bar graph. A regular bar graph, the sides don't touch. Now notice we were talking about A, B, C, D, F. Or you might have one that's like vanilla ice cream, strawberry ice cream, chocolate ice cream. So that wouldn't really lend itself to having the sides touch, would it? These are more when you've got those ranges you're dealing with. A lot of times those are histograms. Now in this case they made it a histogram, so it can be that way. But a histogram, the sides touch. A regular bar graph, they don't. And then remember, when you're making your pie chart, you're going to have your percentages to make a pie chart. Okay, that's it for this one. See you next time.